This is Rust in Production, a podcast about companies who use Rust to shape the future of infrastructure. My name is Matthias Endler from Kiril, and I welcome you to this very special episode of the podcast. I had the pleasure to travel to Berlin and meet with Scott Chacon and Kiril Videlov from Git Butler. We talk about GitHub, Git internals, and how the team at Git Butler is refining Git branching with Rust. Scott, Kiril, thanks so much for having me. And if you have a few minutes to introduce yourself, that would be amazing.
Yeah, thanks for inviting us. So my name is Scott Chacon. I was one of the co-founders of GitHub way back in the day. I'm very old. And today, Kiril and I and Anne have started a new company called Git Butler. And so we're spending all of our time on that, which is partially written in Rust, which is, I think, why we're on the show. Yeah, that's me.
All right. Thanks for having me on the show as well. My name is Kiril. I'm a software engineer, co-founder of Git Butler. I've been working with version control stuff for a number of years now. So I'm kind of really, really excited about what we're building at Git Butler.
So a couple of weeks ago, I was at the We Are Developers conference, and this is where I met you guys. But in fact, I know one of you at least for a very, very long time because, Scott, you wrote a book called Pro Git, and yeah, you taught me Git back in the day. It's kind of crazy, and it was amazing. So I know that you are amazing when it comes to communication, when it comes to developer products. I guess you care a lot about developers in general. And what I find interesting about Git Butler is that I think it's an iteration on what you did before. So it's maybe you can express it in your own words. How would you describe Git Butler to someone who maybe is aware of GitHub and Git already?
Yeah, I mean, I think kind of the impetus for this was a product that Kiril had done before, which was called Sturdy, and it was a different take on version control that was kind of asking questions like, why is version control not more like Google Docs, where you're not committing stuff, but it is doing version control, right? Like there's other ways of doing version control than how software developers do it. And I found that really compelling of just rethinking sort of the client. I think GitHub did a relatively good job of making sort of how people were using mailing list type things approachable. But we never really owned the client, right? Like when we never really tried to make the client experience better. We just kind of relied on Git and all of the existing Git clients, most of which wrap the Git CLI and those commands. And nobody really stepped back and said, if we did this from scratch, how would we do this, right? If the GitHub guys sort of created the client in the first place, what might it look like today? And I find that fascinating. So I think that's kind of where it started. And it's an interestingly difficult thing to do, right? To go to first principles on something that you've been using for a really long time. Like Git's been around for, I mean, like you said, that I wrote Pro Git, the first version of that in 2009, right? So that was 15 years ago. And so there's a whole generation of people that have never used anything other than Git. And so to take a step back and say, let's just throw everything away and figure out what can we imagine would be an ideal workflow, like not sort of leaning on anything that came before, what might that look like? And that's exciting to me every day. Like it's always fun to work on. It's always fun to reimagine kind of review processes or how to share work or how to talk about work and how to get work integrated into some sort of production mainstream, line. And so that's where it started. It's actually kind of funny because I feel like, you mentioned Pro Git. Like I think one of the reasons that I've been successful in these things that I'm doing is that I'm not very smart. So I think, if Linus or something creates a CLI, version control system, it's really hard to use because he's very smart and he just assumes that everybody else is going to take the time to learn it. And I really struggled with it. And so when I finally figured out kind of how to learn it and use it, I started writing about it because I was like, this took me way too long to do. And so I wanted to, and it's kind of the same with the CLI, right? It took me a really long time kind of to learn how to be good at Git. And so I want to make something that makes you be able to do the same things where you're not worrying about that and spending your time and your effort on how do I rebase, stuff properly, but to give you the same tools, but make it much more approachable and much more easy.
A while ago, you wrote a blog post that kind of became a phenomenon. It was on Hacker News. I saw it all around the web. It was titled Why GitHub Won. And in that article, you also compare Git with things that came before Git, like SVN. And sometimes it helps to learn from the past. Are there things out there that you got inspired by when starting Git Butler? Any new ideas that have not been integrated into any version control system right now?
Yeah, there's lots of stuff. I mean, there was lots of stuff in like I said, in Kiril's product Sturdy, where it would kind of be live streaming the changes that you're doing. I think one of the main things that we looked at was I feel like the Git commit is overloaded. And so like you use it to save your work. So people do like work in progress commits, right? When that's not really committing, it's not really documenting a change. It's just saving your work, which I think is kind of stupid. Like with Kiril's, you didn't have to do that because it was constantly saving and it was constantly pushing in the background. And Git Butler has this timeline thing that kind of does a version of that I think is really nice. It also, Git commit is used to share your change. You can't push anything over the wire unless you commit it. So people will also do commits just to be able to push it somewhere, right? So one is saving, one is sharing, and then the third is actually documenting, which is what people think it's used for, right? But it's actually used for all of these other things, and it's kind of overloaded to do these things because it's the only way you can do them. And I think being able to separate that in a client is one of the main important things that we want to try to hit first, right? Is we're backing up your stuff whether you commit or not. Or we're able to save and push that and share that with people whether you commit or not, right? Like even work in progress stuff you can get some review on, right? And then you can use your commits to actually have a nice documentation of what you're doing. And so yeah, there's a lot of I think tools that came before. Even like, I feel like we were trying to solve one very specific problem with distributed version control systems, but we lost other strengths of centralized version control systems. Like they're not all horrible, right? Like being able to say, hey, I'm working on this file. Like we all got frustrated. Those of us that are old enough to have used centralized version control systems, like you get frustrated that a file's locked and you can't edit it, or you can't, if somebody locks it in Perforce or something, right? Like it's very frustrating, but you know that they're working on that file. And so, or if it doesn't necessarily mean we need to get to the point where I can't edit it, but it would be nice to say, hey, did you know that Kiril's working on that too, right? Like you guys are probably going to have merge conflicts at some point. You might want to look at that before it becomes too bad, right? The way that people tend to do it with sort of GitHub-based workflows now is, you work on something, somebody else works on something. Whoever merges first has 0% of the work, and whoever merges second has 100% of the merge conflict work, right? And so, like, I think there's there's some middle grounds in some of these things where we can look at older systems and say, what were they actually good at that Git and GitHub is not good at, and what's interesting from BitKeeper, or what's interesting from mailing list patch workflows, right? Like there are interesting things that they did that they do better than the workflows that we have today with sort of GitHub pull requests. And I think trying to learn from that and pull that into how can we productize that in a way that GitHub might have, right? Like that makes it accessible and easy to use. I think that's something only a slightly stupid person can do, because you have to get frustrated by it, right?
One thing to add to your answer, like one thing that I think I did wrong in my previous project in version control was trying to reinvent everything, right? Like trying to reinvent version control entirely from scratch, or like inventing the snapshotting entirely from zero. And that is very difficult. It turns out that Git is really, really good at that part, but it's also really difficult to have people adopt something that is not compatible with Git, because Git is not just a tool. It's a format. It's a protocol. It's a protocol for distributing the software from your machine or from CI to a production environment. So I think that's a big one. So I think what's really interesting that we're doing at the moment is we are thinking about the workflow and we're thinking about the user interaction, but at the same time always producing compatible data structures, like Git data structures. So at the end of the day, what the two outputs is just Git trees that become branches, and you can have that consumed by other tools that are in the ecosystem.
I interacted with Git mostly from the command line. So I typed in my commands and then it would do something magically. But behind that, there's this .git folder, which a lot of people might know of, and there's an entire structure of objects and hashes and so on. Is that ill-specified, or is it in effect really well specified so that you can re-implement parts of it in Rust?
Some is, it depends on what you're trying to abuse, right? So like there's a couple of libraries in Rust that are very good. libgit2 is or Git2RS is built on libgit2, so it's actually C but has the Rust bindings. And we worked on that at GitHub years ago. And now Git Oxide, and we work with Sebastian on trying to see which is sort of faster implementations of these. But the actual data structure in Git is relatively straightforward, I think, most from what we're trying to do. But we try to do some other stuff. We're learning some stuff from Jiu-Jitsu, from some other systems, and we want to inject things into the header. And it took us a while to figure out. There's no like RFC on sort of Git like formats or protocols or anything, right? Even like some of the server protocols are still documented by me, like just like learning it, but like no, it's not written down in lots of places, right? And so it's you have to kind of guess what's going to break because there's lots of different implementations. There was one of the problems with Git is that there was no like standard linkable library for a very long time, which is why it's called libgit2, right? Because originally it was libgit.a, but it was non-reentrant. So it just, anytime you hit an error condition, it would just exit. And so you can't link anything to it because it'll just kill, a GUI or whatever. And so they had this like Unix philosophy of just shell out and run these commands and fork exec. And so, yeah, now it's difficult to know what did JGit do, the Java implementation, right? Or what did libgit2 do? Or what does core Git do? Like, if it sees a null byte here, is it going to explode? If you add a header in the wrong place, like which of these implementations is going to have a problem? Will Git Oxide, it re-implemented a lot of this as well. Will it have a problem? And so since they didn't have a linkable library, there's just 15 re-implementations of this that different people use, and so we have to be a little careful of or try it out in lots of things if we're going to do something that's very non-standard, something that core Git wouldn't do, and be like, is this, I know it's not core Git, but is it acceptable? Will everything else ignore it so that we can use it, right? And so that's always kind of fun.
Did those implementations diverge over time?
They've tried. Diverge in that nothing does everything that libgit.a does, right? Like that the core Git library does. So even libgit2 only does, maybe 80% of stuff. Like there's even, stuff that was merged maybe a year ago, ref table stuff that isn't, that it doesn't work at all, right? In libgit2 or in Git Oxide or in probably JGit even though Sean came up with the spec 10 years ago. But yeah, it's so it depends on what you're trying to do. I think most of the core stuff is, the old pack files and loose objects and all that stuff is very standardized. Submodules, like once you start getting into things that 10% of people use or 5% of people, then it gets a little bit more iffy. A lot of the stuff in Git in the last, 8 years or so has been done by GitHub and Microsoft and GitLab and stuff like that are mostly server side anyways. Like it's trying to scale large server sort of implementation. So most of us don't run into it when we're doing it on client stuff. And that's a lot of the stuff that isn't implemented everywhere because it's just not worth it for most implementations. But yeah, it's definitely, it's not standard, right? Like there's lots of different degrees of percentage of implementation from these different libraries.
Mm-hmm. It makes it pretty hard, or at least in my mind as an engineer, I wouldn't even know where to start. So I wonder, Kiril, when you started working on the predecessor of Git Butler, Sturdy, how did you get started with that? And did you just literally pop up .git folder and then start implementing?
The error in my initial approach was trying to implement a brand new incompatible implementation of a version control system, right? Mm. So that was not even attempting to be compatible. So I think I'm ill-equipped to answer this in a good way. We tried something that was, so we had a file system watcher that would observe what happened on disk and then pick those changes up and attempt to create a snapshot and attempt to record that snapshot and then do that continuously, and then handle the various corner cases that you can encounter accordingly. And that particular bit is really, really hard. So it was not long until we kind of, at the time, gave up on this approach and kind of shifted towards using Git as an engine, as a database for what we're trying to do.
And did you shell out to the command line to use Git?
So for applications that are trying to do something with Git, there are a number of ways of trying to do it. One is, shelling out fork exec to the Git binary, perform the command, and pick up the output. And that kind of can be limiting, and it can also be slow if you do it in a kind of tight loop. So for a lot of things, we would use libgit. libgit2 rather, in order to actually bind a proper library that would interface with Git structures. And for Git Butler, this is our approach that we take in Git Butler is we use all three. we have libgit through a Rust crate. So we're interfacing with libgit2 rather, and we do a lot of tree manipulation or modifying Git data structures that way. And then for certain operations like fetching and pushing, it is difficult to do that with libgit because of differences in operating systems. The libgit2 has its own transport for SSH, fetch and push, and that is difficult. So specifically for those operations, we fork exec. And now, since recently, we have been playing around with Git Oxide, and Git Oxide is attempting to be, a Git library, a Git compatible library, and that allows you to do the same things that you could do with libgit2, but ideally in a faster way, ideally in a more flexible way. And it is faster. It is faster for a lot of use cases.
Yeah, it's interesting. In the early days of GitHub, this was one of the first things that I worked on when I started at GitHub. Was we were fork execing everything, but like fork exec has a pretty big overhead if you're doing it thousands of times, right? And you're trying to do it in one web request or something like that. And so I would go in and look at what was the slowest and try to re-implement those things in Ruby, like in pure Ruby, because that's what we were using on the back end. And we're kind of doing the same thing, right? It's like if we can take a fork exec overhead, it's almost always faster and definitely compliant, right? If we can do it in libgit2, then there's a nice interface for that in Rust, right? And it runs in C and it's fairly cross-platform. And then if we can do it as fast as possible, like if we can do it in Git Oxide, then it's nice because it's purely in Rust, right? And so like now it's not even doing the C bindings or anything. And so yeah, I mean, it's fun. It makes for a really interesting code base.
I've not shared this with you, Scott, yet, but
oh no.
So recently we migrated the way we fetch the branches data, or listing just branches in a repository. We're now using Git Oxide for that, and it appears that at the minute, we have the fastest client at fetching all branches. Like if you have so the test repository had 20,000 branches, which I think is a ludicrous amount of branches. I don't know who needs that many, but in that scenario, our app is currently faster than the CLI in answering the question, what are my 20,000 branches?
How do you measure that? Do you have some sort of benchmarking tool for this, or how do you do that?
A very primitive timestamp-based approach.
And you get some granularity by having a lot of branches and working with big repository, I guess.
So the particular repository is the GitLab repo, and that one has a lot of branches. I don't know why, and just listing them, all of them in the CLI is a little bit slow. And we do it faster. So.
Maybe it sounds almost tautological, but at some point you needed to decide what language to use to write Git Butler in. And of course, you could have picked C, but you could have picked any other language, but you chose Rust to do so.
So for our use case, I think it's not necessarily the language characteristics that were a driving force, but rather the ecosystem or the libraries and the tools that are available. In particular, in terms of what we're trying to achieve with the application. So we're building something that manipulates Git data structures on your computer. So we need to be able to interface with Git and with the file system in a good way. We need to be able to create custom user interfaces. We need to have that set up in a secure way, in a performant way. We need to be able to cross-compile for different platforms. And it just so happens that on that point of being able to create custom interfaces, there is this toolkit called Tauri. So Tauri is a framework or a toolkit that allows you to create desktop apps and use web technologies for the user interface. In a way, it's similar to Electron, but what's different from Electron is they use the native operating system WebView, so they don't need to package the Chromium with the binary, and also they have a very strict and specific way of communicating between the user interface code and the core of the application with the positive impact for security, right? So yeah.
No, I was going to say I just from I was trying to remember us talking about this like when we first approached it, because we did his so Sturdy was an Electron app, right? Right. So he had some Electron experience. I obviously, I came from GitHub, so we did Atom and extracted Electron out of it, and so I even wrote some documentation for Electron or for Atom actually back in the day. And so I was familiar with that, but like when we were looking at how do we build a desktop app that is interesting, right? I think those were really the only two options that came up that could, we could easily put it out on all the platforms that we wanted to. It worked more or less the same. We could do the user interface in HTML and JavaScript. And then really the question was the difference of the backend. Is it going to be a Node or is it going to be in Rust?
And there was a Node backend for a couple of days.
Yeah, I mean the when it comes down to it, I hate JavaScript, but I don't think that's actually what the deciding factor was. I think the deciding factor was A, we assumed that it would probably be faster, and B, we want to do a CLI, I think, version of it at some point. And so it was kind of a nice concept, to me at least, that we could have the one user interface be in HTML and JavaScript, the backend, sort of the core crates and stuff, be entirely in Rust, purely in Rust with nice APIs, and then we could write a CLI interface or TUI interface or something that would have all of the important stuff already done, right? And it would kind of work the same everywhere. And CLIs in Rust are much nicer to distribute than CLIs in Node, right? And so all of those things I think were kind of what tipped us over. I mean, it is nicer that it has smaller binaries because of the using the operating system's sort of default web view, but it also causes some issues because we don't control it, right? And so like there are problems with some Linux distro using some ridiculous web view that we have to debug and be like, why isn't it working on this thing, right? So I feel like that's pluses and minuses, but the idea of Rust being sort of the core library that we can throw whatever user interface on to do the things that we're hopefully is battle tested and good at, and not have to rewrite it in Swift and rewrite it, do it in a bunch of different languages or something per platform. Like all of those, I think, made it fairly clear that Tauri would be a good idea.
It's surprising because I don't hear that a lot, that people come to Rust also because of the nice UI libraries, and it feels like that was at least some factor. I don't know if Rust would have been a non-starter if Tauri didn't exist. I don't think so. Maybe you would have split it up and maybe kept the backend written in Rust and the front end written in something else.
It was certainly the gateway drug, right? Like
we never. I don't think we ever would have chosen Rust if it
nobody on the team. Nobody on the team had Rust experience, so we started working on this with zero Rust background.
Yeah, it was a struggle for me. I haven't done systems programming in such a long time. Like I'm a Ruby guy, right? And like I'm coming in, I'm like, why can't I just?
I've seen the light. I think it's fantastic.
I used ChatGPT a lot in the first days, and then I sat down and read the Rust book. Thank God, it helped a lot. That was the first time I'd even thought about the stack and the heap in like since I was from college. It's been such a long time.
We had Steve Klapnik on the podcast just a couple episodes ago, so shout out to him.
Yeah, he's in the JJ Discord, and we sort of said hi to each other there not too long ago as well. He actually wrote, like, speaking of other version control systems, if you've done something on Jiu-Jitsu yet, Steve wrote like the tutorial book for that. So if you do want to learn Jiu-Jitsu, you have to kind of find his tutorial book that's online somewhere and read through that, because it's a great sort of intro to that system.
Yeah, he also mentioned that on the podcast. So yeah, definitely if you want, you should definitely check it out.
I've only sent one patch via jujitsu, like one actual thing, and it was to correct some stuff in that tutorial book. So I'm also a co-author. I'm kidding. There's like it's like a change of 2 lines or something, but I used that to learn how to use that system. Actually, it was pretty cool. Thanks, Steve.
Kiril, you had some previous Rust experience before.
No, none of us.
Okay.
Nobody in the team had any Rust experience.
Wow, okay. And how long did it take the both of you to pick up the language? It's not a competition. I'm just curious. Is it days, weeks, months, years?
There are really different levels of competence. Like you can get started with messing things up very quickly, right? But to be truly productive and to truly know what you're doing, maybe like a month or something.
What's your background?
I mean, I'm a software engineer, so I've done a number of languages. I've enjoyed Go. I've done a bunch of Java. I've done some C. I had a phase of really being into Clojure. Like I really liked the Lisp style of programming.
But essentially, you have a different background than Scott.
I mean, he's much more hardcore programmer than I am.
I mean, computers are cool.
I've just done. I'm a very practical programmer. Like I like whatever gets the job done easiest, and so that's usually been Ruby for me because I usually do websites. And so I before that it was PHP, but I've been doing Ruby for 20 years now at least. And I'm very comfortable with it. And anytime I try to do something, it usually comes down to that. Unless if I'm trying to do mobile apps, I'll do like React Native or something because, Expo is like a nice, I'll do whatever's easiest to see if an idea works, I think. And so for Rust, I kind of still learn the minimal amount to get something to work. Like I'll throw a patch in every once in a while, and then, somebody will come in and be like, Jesus, Scott, and, make it, they'll fix it. But like, I'll get it to work and make sure that it's even a good idea. Right. And so that's, I'm old enough now that I don't have to learn new things.
But if you can maybe remember one of the things that you learned from Rust, which turned out to be surprisingly good, what would it be?
I mean, I like, yeah, again, from the Ruby world, it couldn't be a more different language, right? And so I do like the compiler stuff. Like it is nice to be like, if it compile, like, most of it is dealing with compiler issues rather than runtime issues. So if it compiles and it actually runs something, then it probably runs the way that I meant it to. Whereas in Ruby, you don't know until it runs into an issue and there's no good debugger and things like that in the same world. But like, it's very different doing systems programming and doing sort of Ruby, almost scripting type programming, right?
The error messages are so good from the compiler. I think I'm still impressed. Like just having the compiler tell you, all right, you move this over here on this line, this part. This is super useful. I think you don't get this in C++, to my knowledge. So
that's also ergonomics. It's
exactly the getting started experience for me was fairly pleasant. Like there is some mountains to climb, but it's obvious that there is some thought put into getting people up to speed with Rust.
I've also found that there's not a lot of boilerplate. Like I feel like when I write, like, I don't know, C code, and I have to do a bunch of header files that kind of, redeclares the same stuff. Like you're not doing a lot of, or Java has a lot of that, right? Like just random bullshit that you're typing out because you have to, not because it actually tells the compiler something that's valuable, right? Or new. Like I feel like Rust is relatively fast to write in. I don't always have the entire memory model. Like I suck at lifetimes and things like that. And so I tend not to deal with them as little as possible until somebody's like, this is not how you do this. But I feel like it's still a fairly succinct language for a systems language, right? I was kind of constantly impressed by that.
It was one thing that I found very difficult while getting started, which is the approach for error handling, or the way you want to structure your application error-wise. Now, I understand that there is the anyhow camp, and then there is the camp of using typed errors, and just finding the balance or understanding which way one would use for, let's say, building a library versus building an application like ours, the trade-offs. Yeah, it is more challenging for... I think there's no right answer, right? Like, and that therefore the ecosystem has not standardized on one thing. Yeah.
Any tips on how to navigate that ecosystem?
Well, I think understand what you're trying to achieve with errors. I think if you, I'm now repeating, I think, advice that I've read, but if you are creating a library, you have one set of, you're trying to set the expectations that other people have. In our case, we are building an application and creating, it so happens that for us, creating types for all the different subsystems and functionalities in our application does not necessarily add the value to warrant the additional type creation and type conversion. So that was creating a boilerplate for us. And we've recognized that, we care about what... So our application works on like an API. So you have commands that get processed. And we do care what happened. We do care if there is an error at the end, such that we can present it in a meaningful way to the user. But we seldomly have the application flow switch on the error types. And for that reason, because we have this user interface that is interacting with the core of Git Butler, we are using anyhow. We're using anyhow, and we're adding context to errors where appropriate, and we're adding error codes as context, in such a way that gets passed on to the front end, and then the front end knows what to do with the error codes.
It was pretty funny having a team coming in that all had sort of different, like we all read books and we all like copied from different code, and so we had like 3 different ways of doing error reporting like throughout the application, right? And then kind of had to go and had to choose one, right? Like figure out like what would be a good way. Is it anyhow? Like is it typed like how, like what do we choose? And now can we go through and make everything the same, right? And it was like waves of, I mean, Kiril did a lot of this, right? Like going through and changing all of the error sort of handling stuff to try to be somewhat consistent, right? But like this is another thing of having a bunch of people start not knowing, like not really having a lot of previous background in this, and just doing whatever seemed right and not knowing, like nobody really had any particular taste at the beginning, but it's definitely gotten better as the longer that we've worked with it.
Yeah, I think that error handling and also structuring an application that is growing and evolving, it's a non-obvious thing. How do you structure it? Do you have one crate or do you have multiple crates?
Yeah, we went from like 1 crate to 50 crates. And now we're like at 20 crates or something.
Actually, it's 31.
How do you strike the balance there?
So
when to create and when not to?
So we started off from a place of having very few, and we had code depending on other code that should not have. So I think when it comes to software in general, I think a lot about this idea of optimizing for deletion. What does it mean to optimize for deletion? It means to be able to say, okay, I don't like this feature, I want to just delete it. And if that feature is intertwined in 20 different places, it's hard to delete. But what I just said is just a fancy way of saying make modular software, right? It's not a new concept. And so we recognized that this was an issue for us. We were adding things, and old things were difficult to clean up. So at some point, we just bit the bullet and started splitting things off. Now, I come from a background of using build systems like Bazel, and there you are really encouraged to make build targets or compilation targets that are small, kind of modular, and this also forces the dependency graph to be unidirectional and very explicit. And I think this explicitness forces you to think about the boundaries, forces you to consider, okay, do I want this to depend on these other things? Or you recognize that, oh, there's going to be a cycle here. It's impossible for me to make it a separate crate. Why is that? Maybe that should belong to this other functionality. Or so we mostly take package by feature approach or crate by feature. We strive to put different aspects of the client in separate crates.
That means if I delete a crate, then I make a couple modifications and it mostly just works again.
This is the cool thing about Rust. Like we've made such dramatic changes to the structure of not just where the code lives, but the interfaces and such. And it all just works because you have a statically typed language, which with a compiler that helps. So if if you can get it to compile, it will work. That's the beauty of the setup that we've got.
Yeah, I doubled down on that as well. Like you were asking what I liked about Rust, and refactoring stuff is so nice in Rust compared to Ruby or any other language that I've done, because you change the one thing to be kind of what do you want this call to look like now, and then it's like here's the 47 other places that you're gonna have a problem with, and you're like I'll just start going through the list, right? Like if you don't have some tool kind of helping you do this type of stuff, it's very clear that you've done your job or not, right? And like 99% of the time you fix all those things and then you run it and it's like, yep, everything works. That's great. That's not in my history of working with software before. So it's very nice.
There is one thing on this subject matter that I've been thinking about, and I don't know the exact answer that is good. So now that we have our code base relatively modular, we have 31 crates. Well, some crates have modules, and in some cases we export the entire modules. And it is more difficult to discover what the API of a crate is when you have like a more nested or like more hierarchical surface area that is exported. And I've recently been toying around with this idea of putting exporting the functions that are from inner modules of a crate, just putting them in the root for easier discoverability, and making it more obvious what the API is and what one can do with something. I do not know if that's a good idea. I would love to hear from somebody. Do you know if this is a good idea?
So there is a blog post by Matt Glad, the creator of Rust Analyzer, and he describes that he likes to keep his hierarchy extremely flat, mostly for pragmatic reasons, because he has a hard time coming up with names for things. And then if you put things into the wrong directory or into the wrong crate and subcrate and module and whatever, then it becomes harder to move that out again. Right. So he tries to keep it as flat as possible. So it goes along the lines of what you just described.
Okay, so not totally wrong.
It's a bit like Git branching. You can have branches upon branches, but at some point I do like to keep my hierarchy flat, at least, because I need to keep track of it in the end. Do you use something like preludes or a glob import?
We avoid that.
Mm-hmm.
I don't think we do that anywhere.
Yeah. I agree, because I literally also wrote a blog post about it, that maybe you shouldn't have a glob import or a prelude for that. That doesn't mean you have something like an application and then on top of it you have a couple library crates that technically you could use for any other reason. For example, interacting with Git itself.
Well, so we have 31 crates, and most of the if you just read what the titles are, they're like different features from the app. And one of those crates is the Git Butler -Tauri. That is the binary crate that bootstraps everything. So I mentioned earlier that we're using Tauri, but we are not really the core of the app is not necessarily dependent on Tauri. We just there is one crate that combines the APIs, sets everything up, and exposes. But then we also have a CLI, Git Butler -CLI crate, which is mostly used for testing, but we have multiple binaries. So nothing in there is necessarily library grade, to be used or to be consumed by, another application necessarily. But we have multiple things that can be built and composed. We can just as easily create a web server if that's what we needed to do out of the API.
Nowadays, there's also Leptos and Deoxys and a couple other UI libraries like Slint. Are you still content and happy with Tauri, or did you run into any issues so far?
Well, I mean, the user interface is svelte, right? So it's basically just, here's a WebKit thing. It gives us a way to invoke calls to Rust. And so I think we're relatively happy with that because, we have a bunch of JavaScript programmers who are good at, we like CSS. We like being able to build user interface with the tooling that we know from building on the web. And Svelte gives us a lot of stuff that I think it would be difficult to go. I find it would be really difficult, I think, for what we're trying to do, which is very doable in HTML and JavaScript, to go down like the Z route, right? Of being like, let's do a completely new sort of user interface stuff, because that's now you're reinventing all the wheels, and it can be much faster, right? Or it can be great for what you're trying to do, but right now I think we're not 100% sure of exactly where we want to land, and it's easier to kind of use the wheels that are there to get us real close to that before we go down some larger, road that's that difficult.
Z builds their own UI library, GPU accelerated and everything, and it's fascinating, but it would be so much more difficult to iterate and try things with such an approach.
We had them on the show, so if you want to check it out, listen to the episode with Zed where they described that UI approach. I think it's nice to compare those two approaches, because I looked at Git Butler and what I found was it looks nice. It's clean, it's snappy, it almost feels native, and I don't know how you pull it off, but definitely you did a great job there.
Yeah, I mean it's an interesting question, right? Like going back to what do we want to build? Like we are still very much experimenting with stuff, right? Like we're all we know is we want to throw everything off the table and then figure out, what do we want to be on the table a year from now. And we're still constantly kind of arguing about stuff, and we try stuff out and we see what works and we use it ourselves and we dog food it and we're like, okay, this feels good. This needs to be changed. This is going in the right direction. Let's rethink this, blah, blah, blah. I think with the Z guys, I've known Nathan for since GitHub days. So, but like, I feel like they knew what they wanted to build, right? They want to build an editor. Like they know what editors look like. They know what VS Code looks like. They know what he worked on Atom before that, and so he had a good idea of like really where do we want this to go down. They had a lot of taste and they knew where they wanted to go, and so I think they could be. It made more sense to say here's what we need a UI library to do, because we want to do kind of this but much faster, right? And so that makes it. Whereas I feel like we have no idea where we're going to land, 2 years from now, what this is really going to look like and how it's going to feel. We know that we're getting closer to what makes us happy, sort of doing these code management things every day. And so, yeah, it really depends on what you're trying to build. Like, do you really know what it's going to be, and making it faster or doing it in Rust or, whatever will definitely help you get there? Or are you inventing? And if you're inventing, then it's much easier to have a general toolkit.
And is it the same experience when you move things around on the front-end side in the UI? Do you have the same feeling like when you do something in the Rust core where refactoring is easy and the language helps you move things around and you can make changes with confidence? Or do you have this, I would say, chasm from the front end to the back end, the typical thing where you change something and then you throw things over the fence?
Yeah, that's really a question of like what's easier or harder in that, like JavaScript or Rust. Like I prefer to do stuff in Rust because I feel more confident that I'm not screwing something up than I do in TypeScript. But you work more in both of those than I do.
I work in both, but my preference would be refactoring the backend. We have the API, or in the Tauri language, we have those commands that are the kind of the thing that needs to be stable, or when we change it, we change it consciously. But yeah, change in Rust is much, much easier.
The other thing I noticed when I played around with Git Butler was that certain operations were snappy, even though they were, I guess, in the background quite complex. And I wonder how you pulled this off. Do you have a lot of async Rust code in the core, or how do you handle that part? Because is Tauri essentially async as well?
So yeah, it's specific. So if you look at our functions, the whole chain, the whole stack, there's no async mentioned. However, on the top level where we define the Tauri command, that there's a macro where we annotate it, or we declare it as an async function. So my understanding of the framework is that it will certainly run this in its own thread, the entire command, but beyond, within that scope, it is all synchronous functions. And this is actually, at some point, we did have async functions in those calls. And as you may know, mixing sync and async code is very, very, or can be painful. There is a constraint for our use case where certain structures that come from Git2 or the libgit2 bindings in Rust, because there is this C operation, those structures are not sent sync. And because of that, they need to be in this sync context. And that made it quite difficult to do certain things. We had to do a spawn thread manually and do certain things. So I think we are in a much better place now that everything within an API call or within a command is sync.
Yeah. I personally also believe that the core of an application should be sync, ideally, because then you can use it in other contexts. As you say, mixing sync and async is not easy. And if you have a library that cannot use async, then you're kind of bound to building a weird bridge between the two. For example, you could technically run that thing on an embedded system, which maybe is not fit to run async code. It could be with Embassy, but it's not necessarily the case. So keeping that separate, I think, was a good decision. And this is how you keep the UI snappy too, because at the end of the day, this macro that you describe, is that a part of Tauri? Is that something that is built into the...
Yes, this is a Tauri macro.
Okay, and they dispatch it in the back end, and then it comes back with the result.
This is my understanding, that they do the dispatching themselves.
Mm-hmm. So all the Git operations, they complete at some point, and then you update the user interface.
So if you look at our API, we have commands, which are things that you trigger, and we have subscriptions, or one subscription, which is for the state of the workspace. So there is things that happen, let's say on the file system, or things that you've triggered in the user interface, and it doesn't matter on which thread that happened, or it's just things that can happen. That is being propagated to the interface through a subscription,
almost like an event system.
Yeah, I think from the Java. So we use the tooling by Tauri, and to me that looks very much like a WebSocket subscription on the JavaScript side. And on the Rust side, we have a file system watching that is observing the file system. If something occurs, it gets picked up, it gets processed, and then we have a channel in which that change is propagated, and then ends up in the user interface or in the JavaScript code.
Mm-hmm. So that's a nice separation of concerns,
right? So there is no need to do polling, for example, in the front end.
How many people write Rust at Git Butler?
Do you count me? Probably not.
I actually
give me a 0.5. So,
well, if we count you, okay. So I want everybody to be writing Rust. So we encourage everybody to, including folks that have, primarily front-end JavaScript background. We encourage everybody to get their hands dirty or rusty, let's say. And
you were waiting the whole episode for that one.
we should do the joke part after this. No, so we encourage everybody to get into this, because everybody's asking for it. Like, it's interesting. It's interesting to try to expand one's horizon, and B, actually, it makes sense to work full stack. With that said, the people who work regularly in the Rust side of the code is probably 3-4 people out of, say, 7.
Yeah.
Yeah.
And engineering wise, yeah.
Yeah.
How does the onboarding work when you tell someone to write some Rust code? Do you just throw them into the cold water? Do you have them go through the Rust book or some tutorial, or do you sit with them for a while?
They just jump straight into it. This is I think this is what we did.
Right into the mind.
Yeah. I mean, there is a pattern that one can follow, right? You can see how. Just let's imagine any front-end developer that has never touched Rust. So the part where the front-end or the JavaScript code talks to the Tauri part, that's obvious. You can see how other commands or requests work. So you can copy-paste that. And then you can search for the string in the code base, and you can see, oh, this is where we declare those. Okay, this is the name of the thing. I can see what we're doing. And you can just copy paste yourself into something.
That's how I do it.
That's how we all do it, And then hopefully you're following a good pattern. And you should be brave. You should try things. I think this is what makes us also happy as developers. Just trying things and seeing what works and what doesn't.
And still, I also do the same. I'm with you on this one. Still, sometimes I wish for some coding guidelines when I start with a new project or start with a new company. I'd like to be a good citizen of the Codebase, right? Do you have something like that? Any internal guidelines?
So we use Clippy. So we have rules. We also, the way I do it for me is I look at other projects. I look at how other projects structure their application logic and how they approach abstracting things, to what extent they use traits and how they use traits, how they, extension traits for certain things, but not for certain other things, or just multiple implementation blocks, just getting into the idiomatic rust. I sometimes would write some code and I would reach out to somebody more experienced on the team and be like, is this idiomatic? Is this how you do it? And then I would learn that you can actually express it in a more beautiful way or in a more succinct way. One phrase that I've heard within the Rust ecosystem, Scott, is this idea or this sentence of make invalid state unrepresentable. So you can express the states of your application or of that particular piece of logic in a way that you can't have the wrong state using the some types enums and such, which is really cool to think about just your programming as putting a puzzle together and just creating a structure that ultimately represents the kind of your application truth or the thing that it's supposed to do and it's not supposed to do, like thinking in terms of invariance.
I come from Python, and it's a bit similar to Ruby in a sense that sometimes I had a larger change and I would run the project for maybe 20 or 30 minutes or so, and then it would crash way down in the stack with some silly mistake that I made because the type system wasn't saving me, it wasn't a compiled language. And I think at GitHub, you had some sort of code style guide. You had something like that. I guess there was something. I can remember you wrote a bit about it on the blog, on a GitHub blog. And at least the code itself was written by expert Ruby programmers. Some of that, do you miss it in Rust sometimes, where there are not those clean guidelines, for example, when to write functional code, when to write object-oriented code and stuff like that?
I don't miss it. Like I said, I'm fairly practical. I do. There's a lot more now, I think, especially than in the Ruby world. There's a lot of stuff like Clippy and Prettier and with like there's I save the file in VS Code and it fixes sort of idiomatically, what everything kind of should look like from a formatting perspective, or tells me when I'm doing something wrong in JavaScript or something. So, I have at least a little bit of a hint beforehand that I'm formatting something wrong or that it's going to look wrong or something. Like there's no spaces tabs sort of like arguments and anymore, right? Like I think the whole industry has kind of moved on from that. But from I don't know. It's like from this type of thing, I think I've been around enough of these where it changes over time, and I've seen a lot of this in the Ruby community as well, right? Where people are saying, here's how you should, do you have, fat model skinny controllers or blah, blah, blah. And they'll come up with something and then everybody will try to do that. And then 5 years later, it'll kind of change a little bit and then you'll like refactor code and the new kids will come in and be like, this is all bullshit, right? And so like I think as long as the code works and customers are happy, like they're not looking at your code, right? Like a lot of it is going to be, what does the next person that comes on, can they understand your code? Can they contribute to your code? I don't like clever code, right? Like I like dumb code that is easy to understand and easy to modify. And so I always kind of go away from super clever stuff because even though it makes you feel smart, it may not, and that's why it makes you feel smart is because somebody else has a harder time understanding it or figuring it out. Like I don't like magic stuff. Anyways, yeah, I don't know. I would move towards as simple and as understandable as it possibly can be, but you have to make the next person that comes on feel like they can own the code too, right? So,
and to your point, if you optimize for deletion if you optimize for making the code base modular, you can always take bits out, replace, re-implement, and swap parts out. I think that's what makes it easier to move faster, because that's one of the things that are really important for us, to be able to iterate on our ideas. As Scott said, we have no idea what we're doing.
How much that may not be the message that we want to put across. We're slowly getting a better idea of what we're doing.
I mean, this is tongue in cheek, but we iterate, we get feedback, and we always kind of need to incorporate those learnings. And sometimes our approach for a particular solution is not ideal, so we take it out, or we want to be able to take it out and replace it with something better.
How much of the code base is functional and how much is object-oriented?
Well, object-oriented, I don't think we necessarily have any object-oriented. Or, I mean, not everything is purely functional. We would have mute, if that's what you mean. We would have things that we mutate. But in terms of state, you start up Git Butler as an application, and there is very little to no state that the application holds. When you get a command or a request, something happens, and now there is more state. But that state goes out of scope when that command is over or has been completed. The only kind of state that is the ultimate piece of state is, okay, which repository are we working on? Like which is the repository, and that's just a path. Mm-hmm. So a path is the core piece of state, and then because if you consider that our application is dealing with Git structures, files on disk, and the Git state, which the source of truth is on disk, not in our application's memory while it's running, and for that reason, after each operation, there is no more state that is relevant. We completed the operation, we return, and that's that. Which I think beautiful. It's nice to not have to maintain controllers that have.
That means you don't have any long-running mutexes, any synchronization that you need to take care of.
Correct.
Mostly depend on the file system, and then you do your next operation.
Correct. So we initially had those because of our background, and we assumed that we did need that, and then through some help and guidance, we've come to understand that we don't need it, and we've been able to take it out. And by taking it out, a lot of things have become simpler. Things that used to get a project controller or a user controller now get nothing. The only thing that you need to know is, okay, which path am I dealing with, and then everything can be derived at any point in time.
It's very cool, because what you said was you optimize for deletion, and that makes a lot of sense in my opinion. And what you said is that you also have a very pragmatic approach, and you want the next person to have a good time. Do I hear that you also want to have simple Rust? You want to have a code base that is understandable? Is simplicity a core value?
Yes.
It's a very soft yes.
No, actually, I want to share a piece for the audience. Early in my career, I watched a video by Rich Hickey called Simple Made Easy, and he makes the distinction between simple and easy, and he talks about the value of simplicity in software. So I watched that talk, and it really changed my perspective on software engineering profoundly. And I have since rewatched that talk together with colleagues at any given time, with different set of colleagues. But I've seen this talk, I would say, more than 10 times. And I think it's really, really valuable. So simplicity in software is a core value for us.
And what's the difference between simple and easy?
Well, I would not do it justice. I think people should watch the talk. But in a nutshell, simple relates to having not interleaving concepts. If you have something that is dealing with, let's say, okay, firstly, you don't want to mix up state and functionality. So that there is that separation. And then secondly, you don't want to have, or you want to avoid this entangling of concerns, like you have a struct that is responsible for this and that. Can it be separate? Is it appropriate for it to be separate? And the difference with easy is, so Rich makes a very eloquent point about how easy is more, relates more to if something is at hand or familiar. So it's a distinction in, okay, familiarity. So this resembles something I've done before. And that familiarity is good. It's great if something can be familiar, but simple has a more pure. And this talk he talks about, actually simple comes from the Latin or simplex, and that means one braid. You're not complecting. I'll not do it. I will not do it in the podcast. But the talk is called "Simple Made Easy" by Rich Hickey. This is the creator of the Clojure programming language. And I had a Clojure phase lasted many years.
Yeah, and in that talk, he also refers to that and says, just because something is familiar doesn't mean that it's simple. Because maybe you got used to it in some weird way. Maybe we got used to SVN at some point, or we got used to the complexity, maybe not complexity, but with the familiarity of Git. And maybe that might not have been the perfect abstraction. We just got used to it, to branching and naming things and rebasing and so on. But those things are easy in a sense that you said is familiar, but maybe not simple, as like not intertwined with other ideas.
Right. Yeah.
And when you talk about deletion, I guess you enforced it somehow, because if you can only delete things that are isolated.
Correct. Yes. Mm-hmm. Yes. So packaging or creating by feature is like a core tenet, like that way preventing the complecting. The word is complect common word in English?
I thought you said it was Latin, so I've never heard the word complect before. So
that's okay.
If it is, I'm going to look it up now.
Yeah. I think that word spiked in popularity in 2011 after that talk. It's
Was that a similar principle that you lived up to at GitHub, where you said make it easy to? Make it simple, deletable, make it isolated, or was it a large code base and it kind of grew organically?
Boy, that's a great question. I mean, it really depended. I feel like I feel like for our user interface, for user facing stuff, it was different, right? Like we really there was a lot of thinking about and understanding what do we present our users, and this concept of everything added dilutes everything else, right? So we didn't want to be Jira or something. Like we didn't want to just add features because people said that they wanted features or said that they would pay for features. Like we really wanted to keep it. We wanted to keep it simple, right? Like we wanted to keep it that there were only so many things you could do, and that we felt that these were the important things to do, because everything else that you add makes it more complex by definition, right? From a backend standpoint, from a code standpoint, from an infrastructure standpoint, I think because it wasn't customer facing, we could experiment more. We had a lot of people coming on at a relatively fast rate at some point, and so like a lot of it just depended on what system you were in and what that particular team cared about, right? Like, did it care about performance? Did it care about maintenance? Did it care about observability, right? Like there were different things that different teams cared about and would optimize for. So I don't know that I would say that, every team had like GitHub had some overarching sort of concept. I think it really depended. It was very, I don't know, tribal, right? Like there were groups and they had their things, and it wasn't like, here's the GitHub philosophy.
When GitHub started, Ruby was also pretty new, I guess, or wasn't it?
I mean, boy, that's a good question. I mean, Rails was new-ish. I think, 5 years or 4 years or something. Ruby was around longer, but I think Rails really kind of picked up Ruby.
It was the prime time of Rails.
Oh. Yeah, I mean, it was when, there's still, Shopify and Twitter and, like all of these. Airbnb, like all of these companies, and they were all in San Francisco, and we knew all these guys, right? And so, like, I think it was a really nice culture of entrepreneurship and building interesting things, right? And having customer focus. Like, it was a great environment for all of that. I think the Ruby community, and like I may have said at the beginning, I think it really helped make Git the thing that won, right? Is because we started, part of the reason I think is we started GitHub and we were giving everybody, we obviously preferred Git, and everybody in all of these communities started using Git to some degree because of GitHub or because of us personally, just we knew a lot of these people. I'm really curious if GitHub hadn't come along, if Mercurial would be what everybody's using now, right? Or something else. But yeah, I mean, like you were saying before, like we're all familiar with Git. There's kind of this local maxima problem, like it's not, there's nothing better than that. It's where everybody's kind of entrenched to some degree. So we are familiar with it. It does have this easy, even though it's not easy, like it's easier than learning something else. So I
Git is not easy, but it's simple.
Is it?
Okay, maybe not.
Maybe. It works.
The reason why I was asking was that back in the day when you started a new application in Ruby, was it a positive signal to the outsiders, maybe investors? I know that GitHub never took any investments as far as I remember, but would it have raised any eyebrows? Or did investors not care at all?
So we bootstrapped until we were 4 years in. We had almost 100 employees from so just sort of a bootstrap background. So when we talked to investors, they didn't care what we were building it on, right? Like we had millions of users at that point, and we had taken no VC, so everybody wanted in on that. So I didn't have normal VC conversations at that time. I don't even now. I do some angel investing, or I've talked to lots of investors about this. Nobody's cared about the tech stack so far. I don't remember seeing it in lots of decks or something. Like I don't know that most investors care so much about how you're building it as much as what you're building. Like that is important. Like is there conceivably a market, right? Like doing it in Rust versus Ruby versus whatever you're familiar with and whatever you think you can move fast on or get to product market fit quickly. I'm not sure that there's that many investors. I mean, I haven't run into a lot of investors who have really cared.
If you talk to someone else, a friend from another company, and they started building up their tech stack, and they were considering Rust and maybe other languages like Go or Zig, what would you tell them? What advice would you give?
I mean, I would say work with whatever the founders or the technical founders enjoy working in, right? Can move fast in. Because you can always go, I mean, Twitter's not Ruby anymore. I think they moved to Scala or something at some point. Like once you find product market fit, like once you start getting users and you start getting traction, like, and you make it, you can rewrite it in anything you want. Like it's actually kind of interesting that Shopify and GitHub and, some of these big companies are still running on Ruby stacks because they still like using it, I think, for the most part. I'm sure there are people in those companies that are like, we should rewrite this in Go or whatever. But yeah, in the beginning, I think honestly from a VC or from a startup standpoint, I would heavily say it does not matter, right? Like we could have chosen Electron. I think we'd be roughly as far as we are today. I think that Rust and Tauri were a better choice for future reasons and things like that. But from trying to find out is what I'm building valuable, I have a hard time saying you can't work your way around. Everything has problems in some way, and everything has strengths in some way. And so, it just depends. I think it's all shakes out. Like you'll work around the problems if you make it.
But that's also a very positive thing because maybe someone is considering to use Rust. Maybe they are considering that it would be harder to get investments, and you as an angel investor, you know how these conversations work. So they shouldn't be concerned about that.
Yeah, no, I don't think from a raising money standpoint, I don't think anybody really cares. I think they'd much rather that you do what you're comfortable with and you feel like you don't have to have a big learning curve, so that you can experiment and figure it out. But it's the same in it's like, what JavaScript framework do I use if I like Java? Like, who cares, right? Use Angular, use Svelte, use React. Who cares? Like, there's pluses and minuses to all these things. It's just, what can we move fast with at first, and then we'll figure it out.
Do you like to work on the code base every day, Kiril? How does it feel to come to work and touch the Rust code? Do you feel, like you're making progress? Do you feel like there's a lot of velocity, like it's maintainable? What's your feeling on the current code base right now?
I mean, it's very exciting. I think it's a little bit like a puzzle that's coming together more and more. It's coming together in terms of performance or fixing issues that people are having. So that's very exciting to me. Like knowing that you fix an issue that somebody has reported gives me a huge kick. Actually, just this morning we made a release, and I know that in that release comes some fixes that I made yesterday, and people have reported those problems, and that feels really good. So that's the part that gives me the biggest satisfaction. But just from a technical standpoint, like working with Rust, it is satisfying. It is interesting because I feel like I'm over the initial hump where I struggle with the systems that are different in Rust, and now I can just focus on what we're building rather than what we're building with. So from that perspective, it's cool. I'm very happy with Rust as a choice. I feel to add to what Scott said, iteration speed is everything. The ability to say, all right, I have an idea, I want to try it and see if it works, and then iterate from there. That's critical for somebody who is making something new and trying to understand if other people want it. So with that said, I mean, Rust can be slower to prototype in if one is not at all familiar with Rust, or if it's something that is... I actually honestly think the user interface stuff would be quite difficult to do in Rust, just because of the nature of user interaction. But for something that feels very functional, like I described earlier with a command that gets executed, that fits very nicely with the Rust model. Like you don't need a lot of state, you don't have to think about state very much. You're transforming something on disk. It's something that you can test in a good way, and then it's a very good fit. So depending on the use case, depending on the kind of context, it can be just the right tool for the job.
You say you're happy with the code base, but one thing that people always criticize are the compile times, the Rust compile times. Do you have any issues with that in your code base?
I wish it was faster. I wish it was link the code. Yeah. I mean, in developer mode, it takes about... If it's an iterative build, and I've made a change to one crate, for us, it takes about 2 seconds or 3 seconds to kind of make the new target and run it again. Of course, I wish it was faster. I wish it can do it as fast as Go. Go is really fast. If I need to build everything from scratch, it takes about a minute. With that said, it's not a huge issue.
I've seen way worse.
Yeah, I haven't. I've never really, like when I'm working on the Rust code, I haven't really noticed it being horrible. I mean, the big thing for us is that we're dogfooding it, right? So we're working on the version control system that we're using to try to version control the version control system that we're working on. And so like we can't have our main code base in the development build of the thing, because then you change some Rust code and it dies, right? Or you do something and it corrupts like your database, right? Like I've run into that several times. So like I have to have the nightly. Now that we have a nightly, it's much nicer because I do the nightly for the Git Butler code and then other repositories with the development build. But like, yeah, that type of thing where it just kill it and then start it back up again was, but I mean, yeah, it only takes a couple seconds, even for this larger sort of GUI type program. It's not bad at all.
We need to keep an eye on the time because you need to go.
Oh, the jokes. We haven't done the jokes. Can we do the jokes? So
yes, but be careful what you say in the podcast. So
okay,
whatever you say will be about.
Okay, I have a good one. So firstly, let me set this up. Well, we at Git Butler have a dad joke culture. We like puns. We like funny dad jokes, to the extent where during our Friday all hands meeting, we do an event where everybody goes on a stage, tells their dad joke of the week, and then whoever gets the biggest laughs wins a little trophy, and then we pass the trophy around. So we got our dad joke off. And yeah, so today we are having an all hands, and I've prepared a joke.
I want to hear your joke.
So what do you call a dog that can make tricks?
What?
You call it a labracadabrador.
That's a good one. I like that one.
Make sure you laugh just as much later when the jury's out.
So last night I was just about to fall asleep, and the ghost of Gloria Gaynor came into my room. First, I was afraid. I was petrified. It's a song. That one didn't land as well.
Didn't land. I didn't know the song.
I liked it.
Oh,
first I was afraid. I was petrified. Is that better? Should I do it that way?
Yes.
Yeah, I got to sing it. I'm so
You
sorry.
should sing it for the jump. Yeah. Oh, this is good. You should sing it later.
He's rethinking all of his decisions inviting us on this podcast.
A friend of mine is trying to date a woman from the south of France, and he was unsure if he could approach her and talk to her. And I said, "Of course you can."
That's a good one.
Oh my god,
That's a good one.
So
you should make this a thing on your podcast too. You should make all of your guests at least share one to start it out
We
with.
should do it on our YouTube channel.
Yeah, we should. Yeah.
Okay, and it has become a bit of a tradition in this show. That's the actual tradition, by the way, to have one last statement about the Rust community. So if you had the chance to address the Rust community as a whole, anything you could say, what would you say? Could be positive or negative, could be about the community, ecosystem, compile times, whatever.
Oh, I mean, I love the crates system and the crates ecosystem. Actually, like coming from sort of Ruby gems and sort of the I don't know, crating the gem sort of system there. I feel like it's or like npm or whatever. Like I actually really, really appreciate how nice it is and how nice it has been to work with and to find stuff and to get documentation. So, from my perspective, I've been very, very surprised by how good that is. And then, from a personal standpoint, I would say it's funny. Steve has been great. He's like the biggest introduction to the Rust community that I know. And I found him in the JJ chat rooms, and he was like, "Hey Scott, thanks for the Pro Git book." And I was like, "Hey Steve, thanks for the Rust book. Fantastic." And then everybody's like, "Oh, these guys," patting each other on the back.
I love the language. Thanks for Rust. Thanks for the ecosystem things. I mean, the libraries have been great.
Yeah, I mean, it's interesting. Like, if we think back, like, we didn't really know at the beginning of this, like, is Electron the right call? Is Tauri the right call? I think, after having worked it in 2 years, we would, I believe we would both probably recommend that somebody use Tauri, learn Rust. Like, I think if we had to do it again, we would do the same thing again, which is actually very nice. Like as opposed to being like, man, I wish we'd gone down the Electron route or something. So we really do like using the system to build our company on, which is not a not scary thing to do.
I have something useful here. And now that I've thought about this a little bit longer, I like that the Rust community is generally very thoughtful for making things in the ecosystem that work and that are relatively well thought through. It's not just tossing crates out in the open and it's like, okay, that doesn't matter. There is some consideration for okay, producing high quality software. I think there are. I was thinking about the dependencies that we use. We have, as we discussed, Git2, which is bindings for libgit2, which works really well. It's documented and it functions really well. We have used a library called Notify for file system watching, and that works slightly differently under the hood for different platforms, but it works for us in a transparent way, which is brilliant. You have Tauri, which has a very, healthy attitude towards security, like the way they treat isolating let's say the JavaScript code from the Rust, which has access to the file system, and just like handling things in a secure way. And not least Git Oxide, which is a piece of software that is, well thought through as well in terms of security, in terms of performance. And it feels like the tooling in the ecosystem produced by the community is of high quality. So I think this is probably the highest praise I can give. Just the median quality of a library or crate that you can find is greater than the median quality of other ecosystems. And I have been exploring languages for many years now, and I genuinely feel this way.
Amazing closing words. Where can people find out more about Git Butler?
Yeah, I mean, the easiest thing is to go to gitbutler.com, and we have links to our source code on GitHub and our Discord, which is kind of interesting. We just recently kind of did this experiment where our entire corporate chat is on the same Discord that is public. So we have some private rooms for just us, but for the most part, a lot of what we do is build in public and it's on Discord. So you can find our blog there, which, you mentioned, I think, at the beginning of this as well. But yeah, gitbutler.com is it's also a really pretty website. Actually, Pavel, our designer, approached it in a really interesting, awesome way that I think is very unique. So it's not hard on the eyes.
Find all the links in the show notes. And I guess that sums it up. Scott, Kiril, thanks so much for taking the time.
Yeah, thanks for having us.
Thank you very much.
Rust in Production is a podcast by Corrode. It is hosted by me, Matthias Endler, and produced by Simon Brüggen. For show notes, transcripts, and to learn more about how we can help your company make the most of Rust, visit corrode.dev. Thanks for listening to Rust in Production.